Hello students, today we are going to write RTL code and test bench for BCD to 7 segment display decoder. Now let's start writing our RTL code. First let's see the BCD. BCD is equal to binary coded decimal, that is the decimal number 0 to 9 are represented using 4-bit binary numbers. See here we have decimal and here we have BCD. The decimal of 0 is 0000 and decimal of 1 is 0001. Likewise the 4 is 0100 and 9 is 1001. So for example, if we give the decimal 5, the BCD representation is 0101. So this is binary coded decimal. Now let's see the 7 segment. See the 7 segment display. That is, it contains 7 LED segments. That is, segment is equal to A, B, C, D, E, F and G. Here LED is on when it is 1 and LED is off when it is 0. So if you look at here A, B, C, D, E, F, G. These are the 7 segment display. And here the Verilog module decodes the 4-bit BCD number into 7 control signal to display 0 to 9 values on the 7 segment display. Now we are writing the RTL code for the BCD to 7 segment display decoder. See, first we are giving the module and then giving the module name and opening the bracket. Now we are going to give the inputs. The input, it means data coming into the module. Here it is 4-bit signal and BCD represents binary coded decimal number. And next the output signal, it is the signal going out of the module and it is 7 bits for the 7 segment. And the 7 bits are segment 0, 1, 2, 3, 4, 5, 6. And it is given as A, B, C, D, E, F, G. And here we are using the reg. Reg is used because the value is assigned inside an always block. And after assigning the inputs and outputs, we are closing the bracket and we are going into the operation. Here the always runs whenever the input changes, and this is combinational logic. Now we are giving the next statement, that is case BCD. Here the case checks the value of BCD inputs. Depending on the value, the correct 7 segment pattern is selected. Now let's see how it is selecting the pattern. You see, first we need to display the number 0. So we are giving 4-bit binary 0000. For the 4-bit binary 0000, the segment is equal to 7-bit binary 111110. That is, it will be displaying 0. How it displays means, you look at this, the BCD is 0000 and here the decimal value is 0. The segments on are, look at this, the segment A is on, B is on, C is on, D is on, E is on and F is on. G is off. So you look at this, the segment A, B, C, D, E, F is on. A is on, B is on, C is on, D is on, E is on, F is on. And here we have the segment G. G is off, so we are not giving it, and it forms the pattern of 0. And let's see the next one. See, in the next condition, that is display number 1. We have to display the number 1. So we are giving 4-bit binary 0001. So the segment is equal to 7-bit binary 0110000. That it will be giving us 1. In this condition, the segments B and C are on, others are 0. So you see, when B and C are on, only B and C are active and it gives the pattern 1. Now we need to display the number 2. For that, 4-bit binary 0010. We are giving segment is equal to 7-bit binary 11011101 and it will be displaying 2. Let us see how it is displaying. Here the segments on are A, B, C is off, D, E is on and F is off and G is on. So segments on are A, B, D, E, G. So you see A, B, D, E, G. It forms the pattern 2. And you see the next one. We need to display the number 3. For that, we are giving 4-bit binary 0011 and here the segment will be 7-bit binary 11110001. That is, it gives the number 3. Here the segments on are A, B, C, D is on, E and F are off, and you see G is on. That is A, B, C, D, G. A, B, C, D, G. And it is giving the pattern 3. Similarly, you look to display the number 4. 4-bit binary 0100. At that time, segment which is on are 7-bit binary B, C and F, G are on. All others are off. So, it gives the pattern 4. Similarly, for the 5, A, C, D, F, G is on and it is giving the pattern 5. You see A, C, D, F, G is on and it is giving the pattern. Similarly, for the pattern 6, A, C, D, E, F, G is on. See A, C, D, E, F, G is on. And for the next pattern, look at this. A, B, C is on. All the other patterns are off and it gives 7, A, B, C. And for the 8th, displaying the number 8, all segments are on. That is A, B, C, D, E, F, G. Everything is on. You see A, B, C, D, E, F, G. It forms the pattern 8. To display the number 9, the segments on are A, B, C, D, E is off, F and G are on. That is A, B, C, D, F, G. Look at here A, B, C, D, F, G and it gives the pattern 9. Now for the decimal number 0 to 9, we have displayed everything. Next condition is default segment is equal to 7-bit binary 0000000. That is nothing but if the input is not 0 to 9 like 1010, 1011, at that time all segments are off. The display becomes black. After this, it ends the case statement and it ends the always block and it ends the module. So this is the RTL code of 7 segment display decoder. Now let's write the test bench for it. See here, first we are giving the module and the test bench name and then we are assigning the inputs and outputs using regend wires. See here BCD we are assigned using reg, that is input using reg and output using wire. After doing assigning the inputs and outputs, we will be instantiating the values. So we are giving the name of the module which we have given in the RTL code and then we are instantiating using instance UUT. After that, we are connecting the test bench input with the module input and test bench segment with the module segment. And then we are closing the instantiation operation. After that, we are beginning initially for the test cases. First thing we are giving as display, that is it prints the text in the simulation console and it gives the output, that is BCD and 7 segment values. Now we are giving the test cases, that is BCD when it is equal to 4-bit decimal 0, perform the first operation and then wait for 10 time unit and perform the next test case. And then when BCD is equal to 4-bit binary decimal 1, perform the next test case and wait for 10 time unit delay. So it will be doing it for all the 0 to 9 test cases, and then it will finish the simulation and then it will end it. After this, what we are doing is we are giving a monitor block, that is monitor initial block. We are giving monitor values. See, another initial begin is used for monitor outputs, and we are giving the monitor statement. In this statement is continuously it prints value whenever any signal changes, and then this is the binary format. So it prints BCD value and 7 segment outputs, that is 0000. For that, what is the 7 segment output? It will be printing it. After performing this, we will be ending it. So it will be ending it. And then this is the BCD to 7 segment display decoder test bench. So students, after this we are going to see lot more codes, and if you want to learn the RTL from scratch, please subscribe my channel VLSI with Dr. Leena. Thank you.